We are back at it. Um, oh God, where were we? So I was basically It's a problem when you just spend a couple days on these and then take a break. um, so I was trying to build these using SymPy, and I was trying to get the expression to actually take in arrays, because at the end of the day, what I want to do is I want to expand that to get the coefficients and be able to build a cubo myself, just by iterating over the elements of the cubo and asking the expression to give me the coefficient. And so where was I? So if I do, the problem is that I was not able to really get the expression to catch the fact that those are arrays, and those components like the mu thing here, the WT and stuff like that. So I had this generate WT here that basically generates the sub expression for like WT, right? And then it returns it as a matrix like these. So if let's comment this out and print HWT and see what happens. NP is not defined. Well, what's this? Q1 forecast return. Okay, so it's returning the matrix, but it's not a matrix, it's a vector, right? But like two vectors. But it's really returning into a matrix form. So just one row kind of thing. Which I'm not sure it's what we want. So if I go and I say, can I just adjust these here? And basically SymPy vectors. It seems like this is gonna do. Oh, I was here already, but I simply like that. So I actually, what if I just say vector? What do I get? Has no attribute vector. Module SymPy doesn't have like. So those are matrix objects. SymPy, so first we import and declare first matrix object. So that is because that is in and of itself an array, then I should return it. Okay, so it seems like I should really return it this way. What am I doing? Print this thing. So that really prints just the No matrix. Okay, so this seems to be the right thing to do. A matrix and an expression. I don't know if I can just SymPy matrix expressions. Matrix expressions. Okay, let's do this. Okay, so you can define a matrix symbol as well. I get it, okay. But it doesn't have to be... okay, so that should work. Let's see, so we have these, and then what we need to do is we need to... I want to multiply the transpose of... okay, so the return... the f return t is an array, so so f return t, right, is basically f returns t is an array, is the returns at time t. So what I want to do is the returns matrix. I mean, it's like, can I not just like... what is the paper? Can I not just say returns like mu t, right? So that would be like mu t. It's basically sp dot matrix, and then we give it f returns t, correct? And so that will be print mu t every time. There you go. Cool. And I can actually SymPy transpose of matrix. Transpose. I'll search for transpose. Also transpose. So simply SymPy transpose. Should I still just call it transpose A? A dot T. I can do T. Okay, I can do dot T, and that will be the transpose, right? So I can just now say that H equals... let's not have the -1 for a second. So I can just say equals mu t dot t. Does this make sense? Does this break? Yes, this breaks. Cannot add class mutable dense matrix and class int. Where? Why not? I'm having an expression. Why you can't do that? Can I just do this? Okay, that seems to work. Just put this here. But I don't want to print these. So at the end, what you have is a matrix. It's a matrix, right? Like that's kind of what you have at the end. Yeah, kind of makes sense. Hmm. Cool, but how do I how do I iteratively add these there? So SymPy empty expression. Can I have something like this? Can I have something like this? Hmm. Hmm. How can I add that iteratively? I don't really know how to do this. Would I just have the like? Do I have to just? Arithmetic, foreign types, task level of symbols, obtaining parts of expressions. So this is the basics of expressions. So you suppose you want to construct this expression, blah blah blah. So they call it a symbol x, and then you just do x plus 1. I want to just create the expression step by step. Yeah, but I guess I have to just at least have the identity, right? Like, can I do these? Yeah. Okay. Cool. I don't know. Is there a cleaner way? I don't know. Good. So I have these. Now I have. Good. Now comes that part here. That is the. This is where we're supposed to be getting some of those coefficients, some of the quadratic coefficients for the QO, I think. And so here we're doing. Oh, sorry. Of course, it does not complain because I haven't really added these. So I don't know if it's really going to work out. No. One record. Oh, positional argument B. What? Simplified rubber. Well, I haven't told. I don't know. Why it doesn't work? I just want to start like. Just want to start like this. Can I just do this? No. No. I want to start with an empty H, and then just. But this also is not working. How do I do that? How do I SymPy build expression in for loop? I mean, I cannot be the only one that wants to do something like these. Maybe with the substitutions then. So otherwise I can't just. Symbolic math variables can be combined into symbolic math expressions. Once in an expression, symbolic math variables can be exchanged with substitution. A symbolic math expression is a combination of symbolic math variables with numbers and mathematical operations, blah blah blah. After the symbols are created, the symbolic math expression using X and Y can be defined. Use the subs method to insert a numerical value into symbolic math expression. The first argument of the subs for substitute against method is the mathematical symbol, and the second is the numerical value. But that's not what I want to do. I want to replace. Oh yeah, expressions can be also substituted by other expressions. Consider the following. So, okay. So I would just say I'll create like, you know, so I split symbol H, and so this is like that. And then what I will do here is I will do yeah, well, basically like if T is smaller or equal than NT, or smaller than NT, right? Because it's going to be from 0 to NT. So once from 0 to NT minus 1. So if it's like that, then I'm gonna basically no, the other way around. So what we're gonna do here is we're gonna do the following. So we're gonna do H equals H, substitute H by, and now this whole thing here, right? And so, and we're still gonna have this part, which we're gonna build now next. And if we're still not at the last time step, then we're also gonna we're also gonna do like basically gonna create. I think I can just say. Can I just say H equals H plus H? So we're gonna add another replacement element so I can replace it in the next iteration, but only if I'm not in the last one. Okay. So does this work? No, H is not defined. Where? Here. Yeah, well, that's the, oh, sorry, symbol H. Cannot add class immutable dense matrix and class symbol. Why not? Why not? Oh, okay. So I guess what this is complaining about is these, right? So it's basically saying that I cannot build the expression recursively like these. Oh God. So what if I just like, does it work if I just do this for now? Also not. Why not? That seems awkward. Like I don't know how to do this. We can conclude is you add any sum of a list of SymPy matrices. My Python list contains SymPy matrix objects, and I need to sum them all. If all these elements are just symbols, then using built-in sum function in Python works fine. So symbols, so I have ls list and then print the sums. Okay, but all the elements of but for all elements of matrix type, sum functions looks not working. That's what I'm getting. Yeah. Okay. This is why Python sum function has an optional start argument, so you can initialize it with a 0 object of the kind you're adding, in this case with a 0 matrix. So I just need to know the rank. Not the rank, but we just need to know the size of the matrix. So the identity. So it would have to. Will have to work. Term more such as okay. So I would need to add a matrix symbol. That's what I would need to add. Maybe that will work as well. So if I just say that's a matrix symbol, right? And then replacing it by these. So maybe that will work. And an M. So I need to tell it and an M. But I'm not gonna know in advance, am I? Because I want this to be, or do I know? So I know it's gonna be maybe I just can start with the identity if this is gonna work. Maybe it's gonna work better like that. So I would need to know what is the what are the sizes here. So for each time step, these things are really size n, right? Like size of the amount of assets, I think. So I think if I just start the identity, so SymPy identity, how do I the identity I, just like that. I is the anti-matrix. Okay, so I4. So I can just say IN. And then I just say not these, but like go ahead and sum these. So what I'm saying is I start with the identity matrix of n by n, and then I add. Yeah, yes, that works. Cool, perfect, that works. Yeah, it feels awkward, but what else do we have? So we have now the risc and the transpose of WT times the covariance matrix times WT, and the risk here is a, oh, by the way, and I think this was supposed to be like that. Okay, now I cannot use this multiplication, I have to use something else. Unsupported operand types for NumPy and the array invitation as a matrix. Okay, so I have to turn that, yeah, that's an array. What's the array? This is the array, so this is what I have to turn into a matrix, which is already a matrix. And so what I have to do is I have to do SP or the covariances. Are these covariances really the ones at time t? Yeah, those are the covariances at time t. Oh crap, so actually I need to add. Oh no, that's okay, that's correct. It's covariances. Ah, okay, so what I need to do is I need to actually do cov t equals SP matrix, and then I kind of do something similar. I do cov t, so I get the right one because I actually have to initialize those two different matrices, and so now this is a SymPy type, and so now this thing should work well. And risk is just the risk; it's just an integer. Matrix size mismatch, shape error. Okay, let's investigate that. But it's not bad. It's really not bad. Cool. I think I'll let me just, I have to pause. I think I gotta go to the bathroom. Can I pause this? How can I pause this? If I press, I hope I'm not gonna finish the recording now. Okay, I think now it's recording again. Yeah, I just paused it for a second. I had to go to the bathroom. Cool. So we have now basically a size problem. How do I check this? Like what the problem is, right? The problem is obviously the matrix, I think, because if I just do this, like that will work. Yeah. Oh, look at this. Look at this. So I'm getting here. Yeah. That's nice. Okay. The actual coefficients like that. But why am I getting a matrix? I don't want to get a matrix. How can I print this in a nicer way? I don't want to get a matrix, you know what I mean? Like, maybe that's not the right product. Matrix product. Do I want, what's the dot product or the inner product? Dot product. I think it's dot product what I want. Yeah, it's the dot product what I want exactly. So I want SymPy's dot product. Maybe that's just another. It's dot. Okay, so I assumed these had to be dot. Okay, so these had to be like that. So dot. So if I do if I just basically do SP dot of these and these, and let's first test these out, okay? That's not true, dot. If I can It's in physics vector. That's not... So am I doing the transpose? Basically, I'm just doing speed transpose. SymPy dot product. Matrices SymPy delimitation. How do I specify the dot product? Dot product. Can I just search for this? Dot product. Just like that? Okay. So I would rather... Okay, so I just have to say maybe that, you know, this is -1 times that, and then I just do and just go and say, well, this is, you know, ut dot, oh, mut t dot, can I do that? No. Okay, yeah, I can do that. But now I have, of course, not a matrix, right? That's the point. And that was my point from the very beginning. That should have just been a 0 because I'm never going to have matrices because I'm always using the dot product. If I do it like this, then it's going to work out. Yes! Yeah. Cool. Oh, man. Just feel... Okay, sorry. Sorry for that. So, I have the risk times the SP transpose of WT, which makes no sense to write it like that when I can just write it like this. And I can also say that is the dot of the cove T thing, and that is the dot of this. Can I chain dot expressions like that, dot products like that? We will now see. Boom. Size mismatch. Okay. Honest SymPy matrices defer to their classes routine. Honest. A 3x1 times a 3x3. Yeah, it's a 3x3. But the covariances, maybe it's not a 3x3, you know? Maybe it's a 3x1 in the sense that it's like 3 possible combinations. No, that's not true either. So, what is the size of the covariances? That actually should be the matrix. That was here. It's an n by n matrix. Yeah, it's an n by n matrix. That's so maybe first of all, let me remove the risk here for a second, and let's just do like these for a second. Does this work? That doesn't work. That's where the mismatch is. Then it's not the dot product. Oh, because maybe that's just the normal product, right? Because you have the transpose. No, but that would be matrix dot product. That's what we want, right? sort of, yeah, okay, but it should be, then I don't know if this should be the transpose, because the transpose is the column vector. Is the column vector, right? Or is that the transpose? I assume the transpose is the column vector. And so, yeah, but then this shouldn't work either, right? Mu t, because it's the other way around. I mean, print ut and print ut transpose. That is a row. And then you have a column, right? The transpose is an actual column matrix. So how can this even work? You know, but this should work, because what it means is, so what these dot means, right? Not these dot, but the, so it's V1, so V3 is, so V1 dot V2 is 32. But I guess I cannot, like, can I do these or it's going to complain? I don't understand. Oh, that's a number. It's then a times x, right? Plus b times y. So it goes through each row and then it multiplies by each column and it adds the whole thing. But because it's only one row, then you end up with only one thing. But if I do the transpose of something, the non-transposed thing, yeah, that kind of works as well, because then you have like these times that plus these times that. But it really shouldn't work, because you should have a matrix, not a number, but you're getting a number, because I'm really confused now. Yeah, that's what I'm saying. It's the whole row times the whole column, and that's the element here, right? And so if you have a vertical, like a column vector, and then a row times a row vector, you're gonna kind of have, at the end of the day, like, you should have a column vector. So why does it give me a an actual number, and now it just gives me something else. I think there's something fishy going on here. So what if I do mu t as transpose, and I call this mu t transpose, right? And now I just let's print this again. So this is these and this is these, right? So now we have these, and we have like one is the row column, the row matrix, and this is, and then it's a column matrix. That makes sense. If I take the column matrix and I do dot the row matrix, that should give me a matrix. It gives me a number. Why? And if I do these, it gives me numbers. Where's that? That's I'm really confused right now. Are supported as well as some useful vector operations dot. Like that should yield a column. A column matrix. Like, you can't just ignore these. That's really confusing. Let me not print anything. Just these two times. It just gives me a number. Yeah. Sorry. Now that makes sense. But if I take the transpose and multiply by this one, they cannot give me a number. Of a column vector and a row vector. The first vector must be a row vector, while the second must be a column vector. Both vectors must contain the same amount of elements. Exactly. So is this just kind of grabbing the right ones? Is 1.9 and 0.63. No. Maybe it's turning it. Maybe that's just. Oh, sorry, what am I doing with itself? Yeah, okay, but that shouldn't matter. Maybe it's just just transforming the input accordingly. Maybe that's what the function is doing. WT. So WT is a row. Dot product is method for multiplying two vectors. The first vector must be a row vector. So that already doesn't make sense in here, that this is the transposed. Oh, I'm getting such a headache. Such a headache with these. So I had to go again. Okay, now, I mean, you shouldn't see anything. I'm pausing the recording, so. Now, I suspect this has to do with something like this is maybe thought for specifically maybe some vector stuff, and it's doing implicitly transpose. So if I just do SymPy matrix or dot product error or something like this. Similar to matrix simplification. In NumPy, it's standard to define matrices and dot products as shown below. But to my surprise, the following fails in SymPy. The method dot in SymPy is meant to allow computing dot products of two matrices that represent vectors. For example, okay, so there is a transpose involved in this. Return the dot product of matrix self and B relaxing the condition of compatible dimensions. If either the number of rows or columns are the same as the length of B, then the dot product is returned. If self is a row or column vector, a scalar is returned. Otherwise, a list of results is returned, and in that case, the number of columns in self must match the length of B. Okay. Then it seems like I shouldn't do any transpose. So it seems to me like I shouldn't do the transpose of mu t sub t and of wt. What I should just do is I should just print like these. Like I should just do, you know, mu t times wt, because apparently this does that implicitly. Yeah. Okay, cool. I think that works. So that does, okay, that works. This means that this means that the first part is mu t, I don't need to transpose, it's dot, like that makes sense. And then the second part is, and that's where it gets interesting. So I want to multiply wt, I want to do the dot of wt and co of t. That's a shape error. Maybe I just have to multiply in this case then. What happens if I multiply two things? Then I get a matrix. Okay, and what is this matrix shape? If I do this, what is the shape that I'm getting? Sorry, it's not a function, it's a property, I think. So just, oh, come on. One, three. It's one column. Is it rows? It's one row, three columns, I think. That's it. Yeah. And I think that I can then now basically do dot wt. Yes. Yes, I think that's it. Oh, cool. I think that's it. Yeah. Nice. Okay. That seems to work. So I think that's what I gotta do. So this is basically... Okay, so what this means is I don't have to... So I don't have to do the transposes. And then I can just also, by the way, just add the rest back again here. And do that. And of course print h at the end. Yeah, nice. But why doesn't it like distribute these inside, like this coefficient with this coefficient and etc., right? Like, Because essentially what I want to get is, now I want to get, for example, print the coefficient of of these, right? It's not defined. Why it's not defined? It is defined, it's here. Oh, sorry. I actually have to. Keep forgetting these. Sorry, I don't want to print H. I just want, because it's confusing otherwise. How is that the coefficient of... Can I just give me the coefficient of these, for example? 0. Okay. That's weird. I guess it's because it's not doing the actual, multiplication as I want it to do. Yeah, of course. What it's giving me is 0.25 times this whole thing here. This whole thing here. That's what it's giving me. Right? I don't know. Is there a way to print these things nicer? Okay, but anyway, so I have these now. Now I have these and these. Now I wanted to get the yeah, I was working on the actual transaction costs as well, and I was saying, well, TX expression 0. Where are the costs? But maybe I should figure these out first before jumping to the costs. How can I get all the terms? So how can I get the whole thing to really give me the coefficient that I want? So if I want to have print H, right? I think I'm going to close some tabs. SymPy print in LaTeX, or can I do that? Can pretty print its output? No, pretty print. How do I set up pretty printing? Pretty printing. Init printing. Oh, init printing function. Okay, so I just use this. It's not defined. Well, maybe I should, Okay, but it didn't do anything. Init printing. Oh. Init printing. But then that's not what I want. Then I want to do that's still not what I want, because this is like the yeah, Python notebook. So SymPy pretty print Jupyter Notebook. What do I get to print something nice? Because otherwise I can't really. In printing. Okay, SymPy version isn't available. Maybe then what? Code example. So there's a code example apparently here. Okay. Speed unit printing. If I do, it's just the same. Symbol Q. Oh, that prints it nicely. Okay. Oh, nice. But how can I? But if I just do print like this, it's gonna print it ugly. Ah, okay. So if I just do, but if I just do Q, it. Oh yeah, that prints it nicely. But then. If I do H. Oh, it's still working on it. Oh, nice. Okay, now it looks better. Oh, nice. Yeah. So, can I, like SymPy, can I just SymPy define precision or decimals? I don't wanna print. I wanna have SymPy. Yeah, or even 2 decimals. How do I do that? So round expression. Really? Actually have to. That's a bit hacky. Round expression. That feels a bit hacky. Not NumPy, but like. No, SymPy, okay. For A in pre-order traversal X1, if is instance A float. Okay. Seems like you really have to do something like this, okay. Then we'll just make a function, like a helper function here. Def round expression. And it just, so x2 equals expression, and so this is expression return x2. Does this do the job? Now we will see. Round expression h. Well, I should probably call this first. Yeah, and then I should just call these. Can I just not copy the code here then? Round expression. Okay. Opa. This looks nicer. This looks nicer. So, round expression. And then I'll say number of digits 2. Number is not defined. I guess what I need to do is probably SB number. And it seems now it's working. Yeah. Okay, perfect. So I have these things. So the term, like the term 000, right, shows up. Like if I do like print coefs, and then I really just, you know, add x00, 000. I'm really thinking, can I have another separator? I cannot have another separator. Whatever. So if I do these, what's the problem here now? Coefs. So SB coefs. Was it this? No, it was H. But I think I gotta do this before the rounding happens. And then I'll just print something like this. Why not? It's not an add object. What the heck? It used to work. So SymPy coefs. Coefficients coefs. What? Why not? What's the problem? What's the problem now? What's the problem now? It used to work before I did any of these. It just worked. Let me copy the whole thing and just go back to... Man, just late, I guess, but... A coef. Oh. Come on. So it gives me that. Can I print it? Can I now print it after this has happened, and then hopefully it will actually print it also with a short. No, it also prints it like these. Okay. Whatever. Whatever. Okay, but you can see that it's basically it's basically printing me these times these. I guess times these and these, right? And then even these minus, okay. So it's really giving me the whole thing here. So how can I make it do the actual product distribution? Compute product distribution? Is it that even the way you call it? SymPy compute the parentheses. Like compute the brackets. Simplification. Yeah, that's what I want to simplify. Simplify. Ah, okay. Okay. Simplify. I can use simplify. Let's see if that does the job. Right before, so if I just do h equals h, or simplify h. That's not what I. Okay, but that makes sense. That makes sense because now it's simplified it this way. So now I want to have. Okay, but it's wrong. I would like to get the minus 0.33. Instead, it's giving me some sort of abstraction, like with all the dots in here and stuff like that. You know what I mean? Factor. For example, factor when called on a polynomial with rational coefficients is guaranteed to factor the polynomial into irreducible factors. Factor. So we'll try factor. It'll still take a while. Okay. What? Ah, there you go. Yeah, that makes sense. So it means it's not like I don't have any coefficient for that. I like it. So what if I, for example, ask for the 110, which there is 1, 110, and I also want to know for the coefficient of, say, can I say, for example, that I want the coefficient of, if I get these done, then I'll stop for now, and because then the rest is a bit. I think it should be easier. I wanna see if I can get these 1.25. Cool. Because with this I can start building the matrix essentially, and so then the rest is just a matter of like whether I get a way to formulate the costs of the transaction costs and whether I get a way to no, 0. SymPy Maybe there's a way to do that that I haven't. Why is this going so slow here? SymPy. Get coefficient of product of symbols. Okay, so I have this expression. Yeah, what is this? Why is it not? Got it. Why is it not scrolling down? Why is this freezing? 11% of my CPU being used. Why? That's it? X2. What is N? All variables in mathematical expressions. I don't know what N is though. Whatever. Like, you know, I could do this by hand, but that's not the point. Is if the metrics gets too big, because then that is, you know, here you have a quadratic term. How do I find the coefficient here? So what do I get? What do I get if I just print, for example, the coefficients? Is it going to give me all the coefficients? Because if that's the way it works, then I can also work with that, I guess. I could also work with that. I just need to figure this out. Once I figure this out, then I basically have... Oh, come on. Oh, expand. Oh, maybe expand does the job, not factor. Maybe expand does the job. Coefficient of 0, 0. Oh, that was quick, but that doesn't do. That gives me the wrong. That gives me the wrong coefficient. Although this is correct. Oh God. Yeah, it factors this thing out, and that's not what we want. I think factors what we really want. Factor really does a good job there. Factors what we want, but I don't know how to get the coefficients of. How do I get those coefficients? How do I get the coefficient of like? So what if I don't pretty print and I just say print age, right? And now I don't know what it's doing. It hasn't factored. where it seems like it hasn't really. Or can I ask for a factor of these, for example, right? For the coefficients of these. No. No, or these, right? SymPy, factor polynomial, get coefficients. It seems that they're not like the actual printing doesn't print things in a nice way. Like that actually doesn't factor. It seems like this nice printing does some factoring as well. I'm just liking the words. Now I realize like track coefficients and corresponding monomials. That's maybe what I want. Yeah. So such B is the dot product. What is it? So I have. Okay. So he wants to get like the coefficients and the monomials like these. The property gen. So the generators halts a tuple of variables in the polynomial. Oh. So that actually. Prod. Pgens. Mon. What? Mon p monums. Oh, so monums. Oh, so actually this monums actually, this is an actual function. What does this return? So what does this return if I, or maybe it's not even. Monums. Does this even work? I'll probably stop here because it's already late. Is this gonna work or not? That's so slow. Curious. There's no monums. It's a multiplication object, but if I just do poly, like I don't know if I can do these. It's probably not gonna work either. Okay, but I need to dig into this a bit more. Oh, look at this. So what is these? So what have we got here? I have no idea what I got here. I have absolutely no idea what I got. Yeah. Well, I don't know. I wanna try to get those things. That's the. Maybe SymPy Cubo, like, does this even like... Yeah, that's my video, come on. Oh, wait a second. Pi. What is this? CuboVert. Don't tell me. Don't tell me there's a package that's gonna do these. That's probably there is. You give it a... Probably give it... Create a Boolean objective function to minimize. Solving the model brute force. Oh no, that actually that actually has solver stuff, solving stuff. To Cubo. So it actually turns it into a Cubo. Solve with D-Wave. Oh, that actually has... So I have the fancy thing here. Where was SymPy? Model add constraint. So you can add constraints and that the whole thing does it for you. But we're gonna do it from scratch, like real mathematicians and explorers. Model to Cubo. Okay, so you actually... I don't know. I really was hoping to do this from scratch, but maybe. Like, I feel I'm so close. I just need those things. I just need those coefficients. If I can get those coefficients, then I'm done. Then I'm really done. This is crap here. Okay. Then if I can get these things, then I'm done. Because then I just need to, you know, do that, and we're good to go. So add the costs and add the other thingy, the Lagrangian thingy, and then we're done. And then we're done with these, and I can move on to the next thing because I'm just there's probably a package or something that does this for you, but I'll have to Google for this. SymPy extract coefficients of a polynomial. So I probably need these to be a coefficients of x, and then it does this whole thing, coefficients x. Use poly and then get the coefs. If I do coefs, maybe that's gonna work. Turn the thing into a poly and then... Okay, my last chance, and I'm gonna stop this. The video, I mean. It's definitely too long. Still running? Yeah. Oh, come on. Yes. Now we're talking. But I really would like to know. So that's 0.09, 0.058. So returns the list containing all coefficients which has a value and ignores those whose coefficient is 0. All coefficients including those where it's 0. Yeah, but how do I know? So it orders it, it's sorting it by... I think that's this one here. I think it's sorting it by like the exponential, because it's minus 0.45, which is this one, minus 0.45. That's this one here. Wow. Yeah, but how do I know, like, you know, which variable? Dictionary comprehension like these. Oh. So you can actually build a dictionary like these. What is these? So x to the power of p. Ah, okay, so it's building a dictionary like that, and then it's saying collect the coefficient of these for each p in range 1 of n. Yeah, that's not what we want to do, though. We definitely want to... Okay, but that's going to be... Okay, but so this is the right thing to do. The coefs. But I wanna still get the actual variables. The monomials. Monomials. Sim pi get of a poly. Is that the monoms thing then? Oh yeah, that's the monoms thing. Okay, so how do you oh, that's the monoms thing, right? It just probably then what, like... Okay, I think I got it. Because then, but what does this mean? Is... Oh, that is... Oh, okay, I get it. So this tells me which variable and what's the power of the variable. So, for example, like 0.07, it's going to be this one here. So it starts with the... okay. But how do I know exactly which one it is, right? Like, how do I know it starts with this one and not another one? Like, what's the... No, that's probably this one, to be honest. Right? Assuming that's the 000 is the first one. 0.16. Yeah, okay, so here you've got like a 1, a 0, and a 1, so it's two monomials, it's two variables to the power of 1. I got it. Okay, so, but I gotta figure out which one is which, right? In this encoding, like 1, 2, 3, 4, 5, 6. So we've got 6 variables in here, and I don't know which one could be which. That's the problem. Like, I don't know which, like 000 or 100. Yeah, that's kind of the trick, but that's what I need. Okay. And with this I can construct a cubo. So maybe what I will do is I'll focus next episode on actually trying to get the cubo done without the costs and without the Lagrangian thingy. Then I'll just add these things later. Because if I can build a cubo like this, I don't really care whether it's the correct one or not. I can just shoot it to D-Wave and at least see if it works, and then I'll just add the other things to make the final cubo, so to say. Just need to figure out which ones are which. Okay, but I'm happy that I got there. Oh man, that's complicated. Yeah, anyway, thanks for joining me.